Today we're working on lesson 3.3, and this is single step equations, and we're focusing on adding and subtracting today. So let's think about what this means. Single means one, step means that there's going to be a process, and then equations is two expressions that are equal to each other. It has that equal sign. Speaking of an equal sign, what do you think that means for our equation? We have our equation, we have that equal sign in there. What does that mean? Hopefully you're thinking about both sides of our equation being equal. It's the first part of equation, is that word equal. So whatever is on the left side is exactly the same as or equal to whatever's on that right side. The left side always equals the right side. Sometimes we've got a bunch of extra numbers that we need to simplify first to see that this left side equals the right side. But in the end, that's what should happen. Keeping that in mind, we have our golden rule for solving equations. And that is whatever you do to one side of the equation, you must do to the other. So think about that equal sign. Think about that balance. That's why I have a scale right here. Because if I take something away from the left side, it's going to be unbalanced. So I have to take something away from the right side as well. Same thing, if I add something to the left side, I have to add something to the right side to keep that scale balanced. Our goal of this lesson is to find out what the variable is by isolating it. So we are isolating our variable. In simple terms, that just means get x alone. X should be by itself. The word isolate means alone. And then we're going to be talking about inverse operations. The word inverse just means opposite. Operations are things like addition, subtraction, multiplication, and division. So, what's the opposite of addition? Subtraction. What's the opposite of multiplication? Division. So the opposite of addition is subtraction, and the opposite of subtraction is addition. And then the same thing goes for multiplication and division. So make sure that you have that written somewhere, especially if you did not know that before this lesson. And then here are your big notes for the rest of this unit, the rest of this chapter. So we're going to be looking back to these solving equation steps a lot. So I might put this on a separate sheet of paper when you're writing out your notes, just so you have this ready for whenever you need it. For my in-class people, I am printing out this and having them glue it to a notebook sheet of paper, just so it looks a little bit different and it's easy for them to find. So I would recommend that you do something similar. So our steps to solving equations is the first thing that we're going to do is we're going to separate our equation at the equal sign. We do this by drawing a line. So if I have, let's say, this equation here, x plus 2 equals 10. I'm going to separate it at the equal sign. I am drawing a big line from top to bottom because this unit is all about that balance. The left side has to be equal to the right side. And so when I draw that line, I can visually see that I have a left side and a right side of my equation. It's super, super important that you do this with every single problem you're solving because it helps you represent that in your mind. Next thing you're going to do is KCO subtraction. So if you see any kind of subtraction, just KCO it. KCO means keep, change, opposite, remember. You're going to simplify both sides. So what I have right now, the left side and the right side is both simplified, but if you saw any distribution or combining like terms, like if I had a plus 3 thrown in there, I would have to combine that 3 and that was rough, and that 2, because those two are like terms before I do anything else. Once you have things simplified, so we'll just combine those two, equals 10. The next thing that we're going to do is we're going to circle our variable. Again, just like that line, that is a visual indication of your goal. Your goal is to get that x isolated. So x needs to be by itself at the very end. That's our goal. Next thing you're going to do is ask yourself what's happening to the variable. And you're doing the opposite. You're doing that inverse operation. So that 5 is being added. It's a positive 5. So if I wanted to take that away and I wanted x to be by itself, right now x is being added by 5. So if I take 5 away, that end result right there is 0. And x plus 0 is just x, which was my goal. That is what I wanted. But remember that balance. Remember that scale. I took 5 away from this side, so the scale is unbalanced until I take 5 away from that side. And when I do that, I end up with x equals 5. And that would be my answer to this original equation up here. Just remember your goal is to isolate your variable. So I did one problem with you. Let's do these 3 together. We're going to solve them and then we're going to check them. Checking them is a super, super important step because when you check them, you know your answer's right. So you know if you're going to get 100% or not on the quiz or whatever you're doing. So let's go back to our steps real quick. Our first step is to separate the equation with the equal sign. Then we KCO, simplify both sides, circle the variable, and then do the opposite. So, step number 1, separate it at the equal sign. That was a little long, we'll redo that. Separate it at the equal sign. Second step, we're going to KCO that subtraction. I do not like subtraction, it confuses me. So, we're going to KCO this. So we end up with Z. I'm going to draw a line through that so it looks more like a Z, plus, because we changed, opposite of a positive 6 is a negative 6. And that still is equal to 2. I don't have any combining like terms or anything like that to do, so I'm going to circle my variable because that's what I'm solving for. My goal is Z equals at the end. Now I'm going to be doing the opposite to both sides from whatever is happening to our variable. So I see that we're adding a negative 6. My question is, how do I make that into a 0? So if I'm adding negative 6, if I add 6 to negative 6, that ends up being 0. And Z plus 0 is just Z. Whatever I do to one side, I have to do to the other. It's our golden rule. It keeps us balanced. So I'm going to add 6 to that right side as well. 2 plus 6 gives me an 8. And that's my final answer. Now I'm going to go back and double check it just to make sure that I get it 100% correct. So we're plugging in 8 to Z. So we are going to, let me change my color, I'll do blue. We're going to take that 8. We said that Z equals 8. That means that Z is 8. It is the same exact thing. They mean the same exact thing, just like what we were talking about at the beginning of this lesson. So since they mean the same thing, that means that I can substitute it into my equation right there. Substituting is just a replacement. So instead of it saying Z minus 6, it's going to say 8 minus 6. And that's still equal to 2. We're going to simplify that left side. 8 minus 6 is 2. So we simplified that left side down. We brought this down. So we combined those two like terms to get that and just brought that down. Now we have the statement 2 equals 2. Ask yourself, is that a true statement? Does 2 equal 2? And hopefully you say yes, because 2 is equal to 2. And that tells me that we have the correct answer there. Let's say that you got a statement that says 3 equals 2. or something like that. Ask yourself, does 3 actually equal 2? Hopefully you tell me no. And that means whatever number you substituted in for your variable was wrong. Redo the problem. So let's look at the second one. As you noticed, it's gotten a lot of writing on it in just a second. So I went through and I solved this problem, but I did something wrong. I know that I did something wrong because when I went and I plugged in this negative 10 into my p, that's my variable, I ended up with negative 17 equals negative 3. That is not a true statement, so I know that I did this wrong. Figure out what I did wrong on your paper or by yourself, and make the adjustment so you can figure out what that variable is. So find out what p actually equals. Hopefully you noticed that I had a negative 7 and I took away 7 more. So those two numbers added together is going to give me a negative 14, which is not what I want. What I should have done was I should have added 7. So negative 7 plus 7 is going to give me 0. So that would go away. Whatever I do to one side, I have to do to the other. So instead of taking away a 7 here, I should be adding 7. Negative 3 plus 7 is going to give me a positive 4. So I should have said that x equals positive 4. And when I substitute that into my equation again, I have positive 4 minus 7 equals 3. And when I solve that, 4 minus 7 is negative 3, and that's what it was originally. Oops, I forgot my negative. There we go. So negative 3 equals negative 3. That checks out, so I know that this answer is correct. I want you to try this problem on your own now. So pause the video and try it out. And here's my answer for it. So what I did was I drew my line. I forgot to circle my variable, so I'm going to go back and do that now. I drew my line, and then I KCO'd it. So I changed that subtraction to plus a negative. I noticed that there wasn't any simplifying that I needed to do, so I circled my variable, and then I added the opposite. So there was a plus negative 5, so I added 5, and that makes that go away, because negative 5 plus 5 equals 0. I'm adding 5 to the other side to keep my equation balanced. Negative 15 plus 5 equals negative 10. I am not going to just take that as my final answer. I'm going to double check to make sure that's accurate. So I substituted in negative 10 for my t. So I had negative 15 equals negative 10 minus 5. Went through and did what I needed to do to figure out that negative 15 does equal negative 15. So I know that this is going to be a true statement. So whether the variable's on the left side or the right side, it doesn't really matter. You're just trying to isolate it on whichever side it is. So I want you to work through all 3 of these problems. So pause the video and check your answer in a second. Oops. And here are your 3 answers, and I have all my work shown for them. So the first one you should have gotten n equals negative 7. Second one you should have gotten y equals negative 15. And the last one you should have gotten b equals negative 8. So now we're going to play a game, right or wrong. So I give you an equation, like this one here, and I give you a potential solution. You have to tell me if this solution is correct or incorrect, so right or wrong. What you're going to do is you're going to take whatever the solution is, or potential solution, and you're substituting it into your variable. So for this problem here, we've got 13 times n, or n is -2, so I'm just going to write a -2 instead of an n. And then minus 9 equals 17. There we go. I'm going to follow order of operations for this after I KCO because I see some subtraction there. So keep, change, opposite. So order of operations tells me that I need to do multiplication before I do that addition there. So 13 times 2 is going to be 26. A positive times a negative means that's a -26. And then I still have that plus -9. -26 plus -29 is going to be a negative number, and it will be -35. On that right side, I still have 17. So does -35 equal -17? Hopefully you say no, because this is wrong. So I want you to try the next few on your own. So make sure you're pausing the video and checking to see if that solution works, and then listen back for the answer once you're done. So is this one right or wrong? Let's check it. So we've got 25 for W, so we're going to substitute it in there. So I have -16 plus 4 times RW, which is 25, and that equals 84. Equals, there we go. Again, I'm following order of operations, so I'm doing my multiplication first and then my addition. So 4 times 25, I know is 100, because 4/4 equals $1. And then I'm just going to bring down the rest of my equation. Now I'm taking 100 plus -16. Since they are different signs, I'm subtracting. 100 minus 16 is going to be 84. And then since the 100's bigger, it's going to be a positive 84. And since 84 equals 84, that is right. So hopefully you said right for your answer. Okay, these next couple are going to go a little bit quicker now that I've explained it some. So pause the video, try this out, multiply, and then add. Hopefully you said that this one is wrong. 1/6 of 6 is just 1, and 1 plus 1 is 2, not 10. So this one is a wrong answer. Wrong or right, try it out. This one you should have said right, because half of 16 is 8, and then 8 plus 1 equals 9. So that is correct. For the last part, I want you guys to write an equation and then solve. So remember our words. So if I'm talking about the difference of something, that is telling me subtraction. So it's the difference, so subtraction, of a number. A number means we don't know what it is, so we're just going to use the variable x to represent a number. And 9 is means that it's an equal sign, and then we have the number 11. So I'm going to box up our numbers. So those are the 3 numbers that we're working with. Remember, that is just x. So we're going to find the difference of a number and 9. So the difference of a number and 9 is means equal to 11. Now I want you guys to solve this equation. So what we're doing is drawing our line. I see some subtraction, so I'm going to keep change opposite it. And then I'm going to go ahead and circle our variable. Now I'm going to be isolating my variable. My goal is to get x by itself, remember? So I'm going to add the opposite. Opposite of -9 is a +9. So that goes away. Well, actually it becomes 0, and x plus 0 is just x. But whatever I do to one side of the equation, I have to do it to the other side of the equation. So I'm going to be adding in 9 to the right side as well. 11 plus 9 is going to give me a 20. And I can double check that by plugging that in. 20 plus negative 9 is 11. And I need to KCO that first because I see some subtraction. So I've got 20 plus change. Opposite is a positive 9. I messed up there. I should have written a positive 9 for my O because I'm looking at the original problem, not the problem that I just solved for. So opposite of a positive 9 is a negative 9, and that's still equal to 11. Now I need to combine those like terms. 20 plus negative 9 is positive 11. And since positive 11 does equal positive 11, I know that my solution is correct. I want you to try to do this for B. Think about what more than means. Is it addition, subtraction, multiplication, or division? So try that out now. So our three numbers are 5, a number, and 8. Remember that a number means that it is x. So this is technically just x. So what we're doing is a addition problem. So more than means addition. If you ever see this word than, that means flip our equation or flip those numbers. So instead of 5 plus x, it's actually going to be x plus 5. Because 5 more than a number. This is 5 more than that x, because we're looking at x as that first thing. And then that is, remember that is means equal to 8. Now we are going to solve. So let me switch over to my red pen. I'm drawing my line. And this is an addition problem, so I don't need to KCO. So I'm going to go ahead and solve. I circle my variable because that's my goal. I see a plus 5, so I'm going to add the opposite, so plus negative 5, which means that goes away. But whatever I do to one side of the equation, I have to do it to the other side. So I'm going to plus negative 5 on that right side as well. 8 plus negative 5 is 3. And so that's going to be my answer. I got to double check myself just to be sure because I don't want to mess up. I'm going to take that 3 and I'm going to plug it into my x. Instead of saying x, I say 3 plus 5 equals 8. And since 3 plus 5 does equal 8, I know that that's a true statement, and that is a correct answer. This is your homework, so it is 6 through 16 even, and then 21 through 25, and that's on page 100 in your textbook. If you've got any questions, send me an email.